Hey, hi, good morning. Are you up? You good? Yeah, it was good. I was managed to have my coffee as well. Well, welcome you to the deep dive about Kotlin. There will be an introductory part at the beginning and some really fascinating and interesting stuff at the end. Well, and to start with, this is something about the language. By the way, are you new to Kotlin or are you... Oh, awesome, awesome. So the Kotlin is statically typed language. So the thing is that the compiler will help you not to screw the program at the runtime for multi-platform applications. It means that you can not only target your programs to JVM, also you can target it to JavaScript, iOS, desktop applications. So you can even run your programs without having the virtual machine on the metal. Sometimes it's good when, for example, you trying to minimize the startup time, or you are not allowed to run the virtual machines like in iOS. Though that's me. The only thing I want to show is the Twitter handle. So if you have questions, you may ask me or you may tweet me. I'll try to process it at some moment later or in the break. So you may spot the thing that's called Kotlin deep dive in 4.2 parts. Those are 4.2 parts. It's an awful thing to say, hey, that's an agenda of my presentation. Let's see it and sleep. No. But still, it is a long talk. That's why I want to have a map or a roadmap for it. So we start with introduction. Then we have DSLs. So it's the basic part. You see the language in action. Then we have a break. That's a 0.1 part. And then we have the second part with multi-platform projects, and I show you how you can reuse the Kotlin between different platforms. And then we have coroutines. This is the way to solve the concurrency problems, but not only, and you'll see it there. And then the last 0.1 part is the end. Okay, let's start. I hope you will not want to write such a program, but this is a valid program. The syntax of Kotlin allows you to do this. So, well, yet another example. What we have here the green block. This is the code we use to write in Java. I bet most of the people will generate such a code with IDE, but still. And then at the bottom, you see this. Should you have a wide enough screen, not like me here, then it's a one-line thing. But essentially, it does the same. So you don't need to write it, type it, support it, think, read. That's enough. OK. Probably you know the answer, why Kotlin is for use, interesting, or why you are here. Well, the first thing, the Kotlin is concise. That's what I shown you just before. The idea is that you write the essential part. You no longer need to write the whole thing like we used to. I want to say, OK, in Java, we tend to write the generic parameters twice, but good, it's not an issue any longer. You have the val or var. And so we have type inference. It helps. And speaking about type inference, the Kotlin type system is slightly different from what we have in Java or JVM. The thing is that Kotlin tells a nullable types from a not nullable types. It means that if you try to access the value from a nullable type, the compiler will force you to have the null check. Or if you try to set the null value to a not nullable value, the compiler will say, no, please check it before. And this helps us to solve the $1 million or $1 billion problem, right? It's so easy to check it for not now, before, not after 1 day or 1 week of this program is trying to do something. And then comes interoperability. And this is a really interesting thing. If you have a new language, what would you do? Well, some would say, OK, we'll drop our code, we'll rewrite anything with a new language. Well, it works if you have a microservice which worth 1 day to rewrite, right? But say you have 5 million lines of code. Is it possible? I don't recommend you. Please don't. It is not. Because you cannot stop the development for 1 year to just wait for the code to be rewritten with new bugs. No. So Kotlin has 100% interop between Java and Kotlin. It means that you can combine Java code with Kotlin code within the same project. So what you can do, you can create unit tests in Kotlin while having the rest in Java. So no Kotlin in production if you want to try it before. Or you can combine it together within the same module. Well, good. And then you start learning the language, you're able to use it in your program, and then you decide. And then you start converting files by files when you really feel the need. But then, if you start doing this, I want to warn you. I had an experience where you have code review, and then somebody says, OK, I fixed this trivial bug in this 200 lines Java file. Well, and I convert it into Kotlin. No way. It is impossible to review such a change because you have no idea what they fixed, and they just rewrote it. So it's definitely better if you do code review or try to see what you do. So to split this. So do conversion as one review and do the fixes as another. Or sometimes you may not convert it if you don't like it. And the final topic here is I'm speaking about a new language. And if somebody will say me, hey, this is a new language here, and we have no tooling. No, it doesn't work for me because I am not able even to learn new language without the tooling. And under tooling, I mean IDE support, build system support, and anything. Kotlin is designed in a way to be toolable. It means that the IDE is able to understand it. Or, for example, it's pretty tough task as we do for Scala support in IntelliJ. It's harder, way harder. With Kotlin, we try to make it easier. And secondly, of course, the Gradle, Maven, and anything is there included as well. Even NPM. So I mentioned that shortly. With Kotlin, you can target the JVM, well, starting from 1.6. So for the people who are still trying to convert to 9, it's too late. But here you can use it with 1.6 or 1.8 or newer version as well. For Android, well, for Android 1.6 is a good thing. Sometimes it's necessary if you're trying to target the whole market of Android devices. Browser and IDE. And I will show you a little bit today. It is possible to write your web UI, CSS, HTML, JavaScript, React, and stuff entirely with Kotlin. And finally, native. Well, that's on iOS, the tiny utilities for your machines. It is possible using the same language and even reusing the code between those platforms. So you have some networking or communication, you need this. It is easier if you have the same language on all sides. Well, oh yeah. So speaking about the Kotlin and Java, this is 100% interop. Well, so you can combine it together, and the tooling is there, so it's pretty easy. As Java plugin, or as Gradle plugin, Maven plugin, or if you like Ant. By the way, you still using Ant, somebody? Oh, thank you. You're brave. Command line is included. Well, for some tutorials, maybe it's nice, but I don't think it's a good thing for something bigger. Well, Android as taught. And for Android, there is, oh, yeah, I forgot this one. The Kotlin is a supported language for Android development. So if you open the documentation for Android development, you'll find out the Kotlin snippets, some documentation, some tutorials. And I want to highlight I'm not sure, I'm not an Android developer, so maybe there is some, I'm sure there are some more interesting things. Or this one I really like. This is KTX. This is an extension for Android development, which helps to develop with Kotlin even smoother than it was before. Of course, it's possible without, but with it is really good. You may find out the Google I/O videos explaining these things and others. For JavaScript, the thing is that it's transpiles, not compiles. This is essentially the same, but just the play of words. And the generated code is readable. And of course, you can use some uglifier or precompiler for JavaScript to make it unreadable and more dense. And for JavaScript, there is a dynamic keyword. It's only allowed for JavaScript ecosystem. It helps to easily develop with JavaScript frameworks where there is no types. But besides that, Kotlin is statically typed. And LLVM and the Kotlin native, well, yeah, it is here. It is beta in 1.3. It's included, and there is no virtual machine required, so it's tiny apps. It's possible to use your application for iOS or Android or whichever you like. So it integrates with C interop. So if you have a C library, you can include it into Kotlin native and use it. It integrates with Objective-C and Swift. So if you have the Mac framework, well, you can import it and use it. Sometimes it's really good to benefit from what we have for a given platform. And finally, when you have so many targets, that's essentially a good idea to reuse your code. Like reuse some business rules or use some the standard patterns, utilities, data classes, data transfer objects, something. And the Kotlin native is for this part. What you have a pure Kotlin code which cannot depend from the platform specifics. Instead, it depends only on a standard library or in other common code libraries. And on top of that, you can create your code, and then it is used for every platform. We'll speak about it more detailedly a little bit later today. Well, this is the picture of the multi-platform thing with the common code and stuff. So you actually can cover all those parts. Oh yeah, and I forgot. With Gradle, you can write, with Gradle 5, you can write Kotlin DSLs for your builds instead of Groovy. Well, they support it for some time, and with 5, it's about to reach the 1.0 as far as I know. So it might be better to understand that what you have in a third inbound closure in your Gradle build. And with Kotlin, it is possible. Well, Kotlin is on GitHub from day 0, so if you wonder what we have for next features, just go ahead and take a look. Everything is there. And this repo is a Kotlin native repo. It's not that fascinating. This is the main repo for Kotlin. Again, it's on the GitHub. And as for releases, so we reached the 1.0 about 2.5 years ago. And by this time, we have 1.3 and a commit graph at the end if you want to see. So it's being developed, I guess, you know. Well, speaking about the programming language is a good thing, but you cannot learn the new language without practicing. It's okay, you can read. There are so many good books to read, but after or in the middle or before, you should have hands-on. And what we do right now, I'll show you some code in IDE. Well, probably you know something about Kotlin, or you might want to join me with this thing. It's up to you. So if you like, you may open IntelliJ, or you may download IntelliJ community. I guess the internet is fast enough to try. And then you can try code along with me, if you like. If not, just relax. The cinema room is for watching, so relax and see what we have on the screen. And anyway, if you have a question, or if you stop getting the point, just ask me. If you don't want to interrupt, or if you see it's not that relevant, probably just tweet me and I'll reply you later on. Well, oh yeah. I like this quote. So essentially I told you that, but yeah, as of my experience, it's way easier to try coding to see how it works, instead of trying to learn without any practice. Okay. Right now we switch to IntelliJ. And what I want to show you here is that if you go into IntelliJ and say something wrong? Yeah. Okay, you go to say new project. There are many ways to start new project with Kotlin, like Kotlin here. So you able to read this? Okay, good. even from the far end. That's indeed good. Thank you. So there are options how you can create your project. And Kotlin Native is included here in IntelliJ. So you actually have the basic support of Kotlin Native included. You can pick, say, just Java. And you can say, OK, I want to have Java with Kotlin. And SQL support. How I can do Java without SQL support? Well, I can. Spring. Of course, with Spring, you can pick Kotlin. And there is a Spring initializer. Do you know something about that? That's the website, right? The same thing is here. So IntelliJ is able to talk to this, and supposedly we have good internet to try. Well, so this is the same UI, same thing. And here, with the Spring initializer, both here in a web page, you can say, OK, I want to have a Spring Boot project with Kotlin and with, say, Gradle project. It is possible. OK. So once we created the project, this is how you start. So here we have the main function. I should be able to run this one. Yeah. OK. In Kotlin, you can create a declaration on a global scope. You don't need to wrap it into a class. It's up to you whether you like it to put in class or not. So you can do this. By the way, you can do this. No, you're supposed to be. Yeah, I have another declaration. OK. Well, this is how it works. So let's try playing and creating a tiny application that would be the hello service. How it works? Well, it will be something CGI-alike. So we will have the names from the parameters, and we will say hello to all those parameters. So we take all arguments here, its name, and then we say hello to them. So hello. This way. And at that point, we created the really complicated microservice, or the service, or the monolith, depending on how you call it. And here we have a suggestion from IntelliJ. It says, OK, you use it this way, but there is a way to make it nicer. And if you apply this one, we can do this. So the string templates are included, so you can say something like that. Even more, say I would like to capitalize the string I tried to say, so I would like to write the name like more correctly. I can say capitalize here, for example. And this is how you can embed an expression into the string template. So if you use curly brackets, well, an expression can go there. That's it. But now, we shall take a look on this code snippet. And you'll probably see a horrible thing. Well, the horrible thing here is that we have copy-paste pattern in action. I mean, we have code duplicates. The essential part of this code is this and that. And those two lines do actually the same thing, right? And let's pretend this is a complicated program and we need to avoid this duplication. How we do it? We extract it into a function, class, module, something, right? So let's create a function which generates this hello message for us. So it takes name, and it returns the string, and it does the same thing. Right. And this is how we create functions in Kotlin. There's a funky word on the end. There is a name. There are parameters. And the return type is on the right. You see? That's a bit different from what we used to have in C-like languages, but you can get used to it. And probably you want to create a variable, and here's the sort of symmetry. So if you create a variable, in Kotlin you can use val or var for variable. So it is done like this. And if you're uncertain about the type, you can specify type. I'm actually lazy to type it manually, so you can specify type this way, again, on the right. And speaking about the val, the trick is that I cannot do this. Because val means actually the final var. I'm trying to refer to the first Java update. In Java, you have var, which is the mutable variable. Kotlin, we also have var, so you can have this. And then that's okay. So the immutability at that point is, well, it's something I really like. No, well, there are two groups of people. The one group like using final in Java everywhere. That's like me. And the second group says, no, I don't like these final variables. And the both parties has their reasons. But the good thing here is that both parties has the only free character keyword to use. So if you like vars, okay, use vars. And IntelliJ will underscore this, highlight with underscore all users just var because, well, probably it's okay, but maybe you do something wrong. Or maybe someone decides to update this code later on in 1 year without understanding where is supposed to be this unmodifiable or modifiable variable in this 100 lines of code. Well, okay, let's back to this example. So now we have the hello message. We can use it here. So I can say hello Devoxx. And I want to say the same thing here. So I do say hello name. Okay, now I fixed my application. Now there is like few parts of code which is replaced. And now I want to show you the shorthand. So this is how we tend to create functions for years in all our C-like languages. In Kotlin, it is possible to make it shorter. You can do it this way. So if you have a function which essentially has one expression as the return, we tend to have so many functions like that. And then you can simplify it. You can say equal sign and that expression. And the second thing is that we just highlighted here. It says that, okay, if we have this expression, Kotlin is able to infer types for us. The same as the val keyword works, the type inference works, and we say, okay, I don't want to write this. Compiler, please infer the type for me. So the function type is the same string, but now it is hidden from me, so I can just concentrate on the thing I do. But now you may say, okay, how would it work if I have Java code? Well, actually I do have Java code here. And this is my Java code, and now I can use it. So this is the main KT. This is a trick. In Kotlin, you're allowed to have declaration without classes, but on the JVM level, it is not allowed to. So what Kotlin does, it creates the class named after the file. So in my case, the file was named main. So the Kotlin compiler creates a file named class named main.kt for Java. And from it, I can call my message. And you see the type here. The type is string, no matter if, I'll show you. So I would say hello. Oh yeah, and I need a semicolon at the end in Java. In Kotlin, it's optional. Well, let's navigate back and I show you. So here I have the function. I have no type specified. But from the Java side, from the compiler side, from the Kotlin side, from all sides, we have this type and it is string. So I can extract a variable in Java and say, well, it is here. And now I want to show you one interesting thing. So this is a JUnit 4. It's the same I will get for, I guess, for JUnit 5. But now I take this one and I turn it into a Kotlin file. So what we see here, that IntelliJ says, okay, you're trying to copy-paste Java sources into a Kotlin file. And it tries to help doing this. So I can press it, and now it looks Kotlin natural. So it is the way, if you have fewer understanding of a Kotlin and you want to try, the first thing you may do, you may just copy-paste existing Java sources into a Kotlin file. Sometimes it will not create the idiomatic Kotlin for you, but it will be definitely a good starting point. And you see yet another trick here. This is the method name with white spaces inside, right? And I can start it. And the trick here is that, so if you see it here, it has white spaces as well in the test runner. So it means that you can have the white spaces in test names even with JUnit 4. And then it's supposed to work for all your tooling like CIs and so on. Because it's this, on a JVM level, it is allowed to have white spaces in the method names. And Kotlin with this back quotes allows you to use it. But unfortunately, it will not work with Android X. So if you're trying to use the white space in the names for JVM, it's okay. If you use it for Android, as far as I know, it is not, because they have a stronger limits for the names. Okay. So now we have a test for our application. We have this application, but let's see if it is the best thing what we have. What I want to have instead of this one, I want to have this. Well, what I have a string object, or you may have an object from every library, existing library. I cannot include yet another method for a string class, right? It's not in JavaScript, at least. In JavaScript you can, but it's a different story. In Kotlin we have extension functions. So you can create extension function hello, which use the hello message from this. Well, behind the curtains, this is nothing more but a static function. And from a Java world, we used to like our my fancy utility class 23 point, create me hello message, the business object, some parameters, some another business object, right? It is possible to make it a little bit nicer here. So what I have, I create this function hello in my module, and now I can de-uglify existing APIs in the way I need it for my particular example. That's it. Okay. So let me assume I want to have this. Even shorter, you know. Sometimes it's good. And what we can do, we can create a variable like this. And now it is possible again. So in Kotlin you have properties, which are, so in the classes you can create properties. The property is nothing more but getter and setter, right? And you can create an extension property. It's declared the same way. So you use a type on the left and name and then a getter, and you can create a var, then you need to create a setter. For example, sometimes you have a getter and setters for some ugly object, and you want to have it for, say, in unit test, you want to have it nicer. This is the way to go. And I want to ask you here, what does this mean? What is this? What's type of this? String. Yeah. So the idea is that this is an extension function, right? So the extension function inside has the receiver, which is string in our case. So this keyword refers to that string. So it's like a parameter, but it's written not as a parameter, but as this keyword. So for example, if I want to get the length of this string, I can simply say length. So here I'm referred to the length property of the type string. I may have done this with this qualifier, but sometimes it's extra thing to write, and I can avoid this. Well, okay, and now I want to switch back to my Java. Well, and I have all those extension functions visible here as well. But of course, no magic. I cannot have receiver, but I can call them. So the hello function is this, and the extension property is turned to the standard thing. It's turned to the get hello. So if you have a the POJO in Java with getters and setters, okay, Java Bean, in Kotlin you may use the shorter syntax without the get foo. You can simply say foo as a property. It just shorten the code you write normally. Okay, so turning back here, and let's continue the dream about this tiny microservice, about the hello messages, and let's assume that our, say, research department found out that our users might be probably happier if they have seen that not hello, but something specific for them. The good case, right? So what we do, we fix the program and say the hello is string, and now I use it here. So I say, so what I actually done, I've created yet another parameter, nothing more. But now I have a trouble because I need to fix all these usages. Like what we do normally in Java, we create an overloaded function, right? In Kotlin, you can do it slightly differently. You can say the default value. So it means that there's a function. There are actually one function which takes two parameters. The second parameter is not necessarily to be specified. And now, of course, you can specify it here like this. It is not the best thing to do, and you can include the parameter names. So you can say this, and you can even split it to the different lines, so to make it a little bit nicer. So this is the way how you call a function with the parameters. And say, assume you have like 5 or many default values, then it might look nicer if you do this. And of course, the order is not necessary if you name them, so you can use it this way as well. And if you decide to do this with Java, now you have a trouble because it says, okay, you need two parameters. From Java, by default, you will not see this. But you can fix it by adding the specific annotation JVM overloads. If you add this, for the Java, we will generate overloaded methods like we used to have before, and now it works. But Kotlin by itself, it is able to deal with this default parameters without generating all the methods for you. So for Android developers, it might be good. Okay. So now we created this one. And let's assume that we have some database and a service to find out the user. And normally we create, so for JVM part, for Java part, we create the podges, right? Like this one, for example. And providing we see all the code here, I want to ask you what is missing here. Well, if you start debugging this application, you find out that toString is missing. Okay, we'll add it. Then you find out that equals hashcode, it's not implemented too. And then if you decide to copy this object, how would you do it? Well, you need to know all the parameters of the fields. Well, in Kotlin, you can do it a little bit shorter. So you can create a data class. Remember I showed this in the very first slide. I create a name. I create the hi message. And this actually it. It has getters. It has no setters while it's unmodifiable. If I have var, it will have. It has constructor, and I can decompile it and show you what we have inside. You see? This is the class which is generated by the compiler. So what I did, I compiled this class. I have the bytecode out of this class, and then I used the Java decompiler to turn it into Java code. Magic, isn't it? Well, and now we can see that this class has two fields, getters, constructor. By the way, the constructor makes sure that we have not null parameters there. It has the copy function. It's an amazing thing, I'll show you. It has toString. It has hashcode. It has equals. Well, the good part, you no longer need to generate this code. The second thing, if you see such a code, are you sure it was generated? Or that might be some fix in there from 10 years. And you now need to add yet another field, and then it's going to be fun. I hope you will now try it. Well, so now what you can do, you can say val, say h is user hello. And now you can call the copy function. This is a copy function. This is a function with default parameters. So we can do this, for example. What it does, it creates yet another object with same fields. But say I want to change one field here. So I say simply the hi. Hi is equal hello. And this function will take care to copy the rest of fields for me. I don't need to code it manually here. Okay. So let's turn back a little bit to the presentation right now. And if you were not getting or missing something or probably something, just take a look at this kotlinlang.org. This is the website with the language specification, all that stuff. And we have a Slack. I think it's 19,000 people in there, so you can join to see what's going on with the community. And I think we'll move the Q&A. By the way, if you have some questions, do you? Okay, that's my point. Okay, let's take a look on the language slightly from a different side. These are DSLs. And this is something you may want to write. I hope you will not, but this is a valid program. You can create such a thing. For example, to model like business rules or create templates. Or this is yet another thing you can write if you need. And speaking about the DSLs, you may take a look on Wikipedia and find out that it's the language, which is not the general purpose, but it is a good language for a specific domain of your application or service or something. And of course, there are the specific DSLs, like the regexp or SQL, or I created new language, or something like HashiCorp configuration language. That's a specific language. And if you create your specific language, you need to deal with the parsing, lexing, tooling, and then you need to sell it to your team, saying, okay, we need yet another compiler, we need yet another build configuration, and so on. Sometimes it's possible, sometimes it's really hard. There is yet another way. We can create the DSLs or domain-specific APIs just in our applications, right? And for this, we don't need to change the process. We can just create the code which is written specifically to achieve this. And there are, of course, examples which we have for many years, like this one. So what I did here, I created the sort of a specific API to create the commit graphs for the JetBrains app source, the code review tool. And technically, it was more or less understandable what I'm trying to say, but it is a failure. The failure is because I have to have this command before the code. So I failed to express myself correctly here because, well, I wrote this code. It is okay. It is dense, pretty dense, but not explaining what I'm trying to achieve here. And of course, there are another example like this. So you can use the Fluent APIs to say, okay, I want to extract something from somewhere. And the good part here is that you saying what you want, but you're not saying how to do this. And that's why it's shorter. Yet another example. This is how you may build the RTF file in Java. Just one long expression to make it. Or this is a DSL which you can use to generate the YAML files. Well, if you don't, well, I don't get the syntax of YAML files. I should have learned it. But if I can replace it with a statically typed thing, well, probably I will screw it less times. Well, so you can do some things like that. So technically, the DSLs are the things which are easy to read, easy to write, and easy to understand. So if you share it with somebody who may have no idea about the APIs or even the programming, chances are they were able to get this, to understand what you're trying to share with them. And this is a powerful concept to use it for the configuration, templates, business rules, user interfaces, libraries, testing frameworks. There are many examples of that. And here are the tiny example. Let's assume we're creating some service. And this service has to generate this HTML for us. it technically no matter if it is server-side or Java or client-side or native or IoT, we need to have this. And probably behind the curtains we have something like that. And if you add some reality here, then you'll have some if constructions, if-else constructions, parameters, variables, functions. And by the way, in Kotlin, if is an expression, so it's shorter to use, or try catch is an expression. So this may not be that ugly, but still, if you're trying to support in this one, oh yeah, I recall the thing, if you take a look on the source code which is generated from, say, JSP, it's a technology from 10 years. Oh, I think, I assume somebody knows it. That's good. So the alternative could be like this. So you may use your language to generate this thing. And for example, do React using some kind of that stuff, or I don't know, JDOM or XML builders, then you can use some APIs to build this XML for you. And here is the same. So instead of using the raw strings, you can turn it into functions, into a program. And at least here, the blocks, they are closed correctly. So I will not screw at least the HTML, the XML part of it. And if it's done correctly, IDE is my side. And I have a code completion. I have year highlighting, so if I'm doing something wrong, I will see it. And at that point, I would say the good part of Kotlin is that the language is designed in a way, it turns out to be really nice to create the DSLs like, say, this. So this is possible. This is a valid Kotlin code, and it's pretty easy to create. And we will see how. And the Kotlin is statically typed, so no matter how many nesting you have, the types are clear, so the IDE is able to understand what you're trying to say, and the code completion is there. And of course, you can use it not only with JVM, but with other platforms as well. So, okay, let's take a look yet another example. And this time, what we have, you may remember this Java client class, which I shown you in Java. So I have a Java API with some POJOs, and I will not be able to modify this part, so I'll be using the Java code as it is. And I'll be trying to use it to create a tiny DSL to make it easier to create these DSLs. So, and again, you may download IntelliJ if you like and try it as well with me. Okay, let's switch back. And now I show you this, I call the package corp, assuming it's probably some corporate thing. And so I have a Java client, remember? I have Java client builder. So I have the standard stack and I have an example here. So what I do in this example, I just create the builder, I fill it, I fill the fields, and then I'm trying to print this out. This is the Java code. We are not allowed to fix it, but we need to make it, we need to improve it. So what I do first, I just copy this part, and I go here to the main function. I think I don't need this one, so we'll remove this one. Assuming we have nothing here, so I just paste this one. And IntelliJ says me, okay, you're trying to copy paste it, let's try to simplify the pain. Let's try to import things. Now I have the valid Java program. And now I guess we should be able to run this one. Let's see what we have here. Yeah. And you see, the thing is that they forgot to implement toString in the right way. Well, happens. It happens. So what we can do, we can create an extension function. Remember I shown you just a few moments ago. So we do create extension functions on a Java client, which is called toDebug string, which returns, for example, so I should say this. Say Twitter handle. And you see the highlighting here, it says to me, okay, you probably are designing it because that's a string in a quote, so I can even remove it. So I can simplify this thing. And now I call it here to debug string. So, and now we run this one again. And now it works. Well, what we've done, we created an utility function which looks pretty good, and we did not have any changes for the existing Java code. As they have it as well. But we have it a little bit nicer right now. Okay. Do you understand this one? So that one is the setter call. You see, so here I have the set function. And in Kotlin, if you have a set function from one parameter, you can use it as a property. So if you have getter and setters, so I can still say the builder set first name. I can say it this way as well. But this is a longer way, and we can use it the shorter way. Well, and now let's try to simplify things. And to simplify things, we need a specific function. So you see here, this is a function, this is an extension function on a type Java client, right? And now we create a lambda. So let's create a lambda. It's called, let's create an extension. I create a function build client, which takes function lambda b, which is Java client builder, to unit, and it's return Java client. This is how you define lambdas in Kotlin. Well, it is the same, essentially the same thing as we have the functional interfaces, but the trick is that you can simply say, okay, I need a b is a function which takes one parameter, the Java client builder, and this function returns nothing. In Kotlin, unit is like void, but the only thing you can use it as a type parameter. And the implementation would be, so we create a builder, which is Java client builder. And then we say b from builder. And then we return builder build. Nothing, is it okay, right? So what we create a helper function, which hides from the code above the way how the builder is created. So instead of creating builder and building something, I have the build function which takes another function which gives me the builder to fill in. I think people tend to have it, for example, in Java, where you say you have some functions like, let's see, I have it here, like, things like do with connection in Java we use. Like you create a do with connection, you pass some callback interface, and the do with connection functions takes care to create a connection, to call us, and then to dispose this connection. The same pattern here, so the run with connection function technically created with the functional interface in Java to make this work, right? Well, we've done the same thing in Kotlin here with barely 4 lines. And now it is time to update our application to use this. So what I have, yep.
I haven't understood the part with the arrow with the name unit.
Oh yeah, okay. So the question was about this arrow unit. So what we create here, we create we declare a type of a lambda of a function, which takes one parameter, which is in parents here. There's a Java client builder. And this is a return type of this lambda, which is unit. And the unit is essentially, you may understand it as a void. So it's like supplier in Java or consumer. I miss them. So that one which have one parameter in there. Oh, by the way. Okay, consumer. Yeah. So essentially the type is like a consumer here. Okay. And now we are updating our application to use it. So we have the builder here. And I need the longer syntax here. It's so hard to write the longer syntax at the first site. So we move it. It's no longer needed. Well, so what we have here, we call our build client function, which is, let me make it visible for you, which is here, right? So this is the build client, and this is a call. So in Kotlin, you create lambdas like this. So you use curly brackets, then you specify type names, parameter names here, and then you just write the code here. Of course, it's possible to have one expression lambda without brackets, but without the same way. Well, and you see here the highlighting. It says to me, okay, I think it is possible to make it a little bit nicer. And let's see, let's apply this one. So the trick is that if you have a function which have a lambda as a parameter, and this is the last parameter, then you can avoid the parents here. You see? So you can even have this one. So if, for example, my function takes some parameters and the lambda at the end, I can pass the parameters here in the brackets, and the lambda goes outside. Why it is good? Well, because it now looks like a language feature, right? Like an HTML in this example before, when I did this HTML. Well, it looks like something pre-designed, but it's not that. It is instead, it is just a function call. So we make it shorter. The next thing is that we can rename this parameter to it. And here goes yet another trick. If you have a lambda with one parameter, it's essential, one parameter, then the default name for that one parameter is it. And that's why you can avoid this declaration. So this it part can be avoided. Nice, isn't it? So it's getting a little bit shorter right now, but still kind of long. And at that point, let's compare those two functions and update our code. You see? So the first function is an extension function, as we learned it before, or in a type Java Client Builder. But if you have an extension function, you can also have an extension lambdas, or a lambda with a receiver, right? So the syntax is pretty the same, so you declare it this way. You see the kind of asymmetry here between this one and that one. So now I can call this function a little bit differently. I can call it this way as well. So the trick is here that I say, okay, could you please pass me an extension function on this type? And then I can call these extension functions here. Okay. And now I'm in trouble. The thing is that I no longer can call it here. Guess why? Because of this. Technically, this. As long as this is a lambda, now this is block is a lambda with a receiver. And the receiver is of type of our builder, which actually declared in Java still. And we don't need to take it and change it. So I can now simplify this one into that. So this first name is still the same setter from the same Java Client Builder class which we have in Java. But right now, we just hide this away, saying, okay, the build client takes care of anything here, and we don't need to bother about it. Well, I think we've done like a part, because here it looks pretty dense, right? So if you create a client, you can simply say, okay, the client name is this, good. But still we have two problems here. It's pretty long, right? And how would we fix it? Again, we create yet another function with a lambda with a receiver. Let's do. So we create a function, say build company, create function. So it takes B, which is Java company builder function. And the result is Java company builder apply B build. I'll explain this magic a little bit later. Now I can simplify the things here and can say company this way. And now I can copy 2 lines partially, see? Well, is it something better? Well, probably it is. And it is not the best. What we can do else, we can create yet another function which is called Java client builder, clean client, which takes this one and which does company that. And now I can shrink it this way. No? Oh, yeah, I should have called this company. Yeah. Okay. Now it's time to understand the magic, right? Well, the first part of that magic is here. Actually, there is no magic here. What we do here, we create an extension function of Java client builder, which is called company. So we create yet another function along with the set company or get company. We create an extension function called company, which takes this lambda, right? And the function does really trivial thing. It just says the company is equal to the build company. And here we use this, it's might be called a functional programming, right? We use the higher order function as a parameters. You know, we pass this lambda to the next function, just as an object. And here comes the second function, it's a build company. And what it does here, it creates the builder, it calls the function on it, and it builds the result. So this code is equal to that one. That one is a long, that code part is a long thing, and this code part is the shorter thing. And apply is a trivial function which simply calls this block. Apply is really the shortener function which you use quite often. So what it does, it takes this left side of itself, this one. It calls the lambda with the receiver on this left side, and it returns the same left side back. So technically this one and that one is the same. And I can copy you this apply function to make it shorter. You don't need these declarations which are here. They are really good, but it's a different topic. So this is how this inline function is implemented. So it takes this Java client builder, it executes block on it. So technically it is supposed to be saying, that's again extension function, so the meaning is this. And then it returns this. And now you can have this one. And the inline keyword here says that I don't want to create those lambdas on a bytecode level. Instead, could you please inline this function with the lambda into the code side? Well, okay, I'll put inline here just for fun right now, and inline here. And now I need to fix this Twitter, and I do the same fix for Twitter. So I just copy this and say here Twitter.
Sorry?
Yep.
Just have a question about company extension function.
Yeah.
So you're basically on top, you are creating a Java builder, Java client builder.
Yeah. that?
No, in the main, where is written company with name and city.
This one or
Line 22.
22? Yes.
This one. So basically, you are creating a Java company builder with these two parameters as a setter, passing to the company extended function of the Java client builder to be used to build the company and return the Java client with that company.
Yeah. So the question was about this company and how it works. So this name is called on the Java company builder. You're right. So, and this function in those brackets, this is an extension function on a Java company builder. So this comes to there. And this company function is declared here. What it does, it calls the build company. So it has this company object at the end. And then it uses the setter on the Java client builder to set this company. So you see it is here. So technically what we have a Lambda with a receiver to build the company builder. Then we have an extension function on the company builder to implement this company setter, the company function here, which accepts yet another Lambda with a receiver to build the internal part. And yeah.
A question about the inline keyword. Is it just an int to the compiler to say inline it, or has some semantic meaning?
I'll turn back to this in like about 5 minutes and I'll answer about. So the question was about the inline keyword. I'll put it to show the feature a little bit later, just in 5 minutes, I guess. Well, let me just drop this Twitter to make it faster. So now what we done? So we started from. Let me show you what we started from. No, not that one. Not that one. We started from that one. Let me drop Twitter from here for a better comparison. And I'll show you two code snippets together. So this is the Java code we have. And here is supposed to be the Kotlin code we created. Let me. And this is, okay, let me zoom it. And that is the Kotlin code we have here. So you may ask me or somebody which one looks better, or which one you can share with somebody saying, hey, I have an example in my unit test saying, okay, is it good, not good? Well, to me, this one with Kotlin and the builders is the way to simplify your tests or your program or your logic or an HTML which you're returning. This looks shorter and actually it shows what the essential meaning of this. And the part on the right side, to me, looks too detailed. It shows so many details in there, which I probably don't need. And if I show it to you, will you get the meaning? I guess you will, but it will take time to parse to understand this whole thing, right? So let's turn back to our slides and see. Okay, yeah, again. This is a good link if you want to find some more things, ask me or take a look on this page. And there are more information about the DSLs. I really like the last link. It's called the type-safe builders. So if you're trying to understand the magic behind, I hope I try to show how easy it is to create. And then you may take a look on this page. It explains how to create an HTML. And then let's turn back to this HTML. What we have here, we have that. And I ask you to stop back, take a look on this, and I hope you're able to understand the meaning of it. So how you create it? You have a function, HTML, which takes a lambda with a receiver, which is the rest, right? And in this receiver type, say HTML builder, you have function head, which is a function which takes lambda with the receiver, which takes another receiver which has the title field or property. It's correctly to say property. And so on. That is it. And this is, by the way, existing thing. This is a Kotlin XHTML library, so if you like, you can take a look on this. And this is yet another example. This is a guarded by. Let's assume you're trying to do concurrency. And then you have some log or some semaphore, monitor, re-entrant, read-write log, or anything. And then you have field which you try to protect with this log. All you can do, you technically can assume that it is done in the right way. But are you sure? Some code snippets, for example, in a Guava, I saw this really good annotation saying, guarded by a log. This is an annotation you can just try to check automatically later to see that the fields are protected. But there is another trick. You can extract the type into the state object. So you put your fields which you're trying to protect into a dedicated object. Well, not so hard, right? Then you create this class, the guarded by, which has this function invoke, and you see the operator keyword here. It says, okay, let's allow to do this. So what it does, it says, okay, this is the guarded function, takes again the lambda with the receiver on type T. In our case, this is a state. So inside this block, the invoke function allows to shorter it to have this. I can access the state, but I cannot access the state the other way. Let's take a look on IDE, and by the way, I'll answer the thing about the inline function. So let's see. So this is the guarded by. Yeah. So this is a guarded by. So this function, and here I have the inline keyword, right? And what I do here, I say the usages. So the guard, and there is invoke function here. So you can call it this way, but with in Kotlin you can override some operators, and invoke is like one of the few you can. So you can shorten it to have it without the function call. So technically, what I do here, I call this invoke function, which takes the log, do the action, releases the log. And the question is, what the bytecode is generated for it, or the equivalent Java code. Do I really create this lambda? Do I allocate yet another object to pass it to the function, to pass it to the other function, and so on? Do I? Who thinks I will create an object in this code snippet? That's strange. Well, I'll try to explain it once more. So I call the function with a lambda, right? How lambda is implemented? Normally, we create an object with a function to run, right? And this goes here, and this calls the log here. So, okay. And now let's see what we have. So there's a bytecode. I don't like reading bytecode, but let's decompile it again. Okay. So what do we have here? I have here that this code is inline, so it is not calling anything here. Let's see where it is. You see, it calls anything right here with a try catch. It does not do anything. This is the power of inline function. So inline function helps you to inline the execution of your function in here. Let me try to simplify it here. Yeah, now we can have it. Let's see the Java code here. And the usage is like this. You see, there is no lambda in here. So the That was actually the trick. So Kotlin is able to inline this Lambda creation. So if you say, okay, we had the really good example with the DSL building before, right? And someone may say, okay, here you have a lambda on lambda on lambda on lambda, and is it performant enough? The answer is yes. If you use inline functions all over the place, then you probably, yeah, let's see what we have here. Build client, where is the main function? So it is anything is inlined here, and there is likely no overhead. That is about the inline functions. And of course, there were some things which I forgot to mention here. And like operator overloads, well, I shown you invoke one, but technically you can overload operators. The standard operators you have in C languages for Java, like plus, minus, unary minus, and stuff like that. You can delegate properties to another properties. Sometimes it helps to create more readable DSLs. You can do delegated implementations or things like that. Of course, you can find some information about some documentation articles. Probably the third one again here makes some sense for you. So it shows, okay, what operators you can overload. And I guess the invoke one is the most interesting. For example, you can create an extension function which overloads the invoke operator for, say, a enum field. It opens the way to create a really nice DSLs. And speaking about the DSLs, how would you create it? I would suggest the following thing. You imagine what you want, you type it in, say, IntelliJ. Then you use quick fixes to create all necessary functions. And you're done. I'm joking. Then you try to implement it with some meaning, some understanding, and then you try this DSL on some examples you have, as long as you're creating this DSL for some reason, right? And then you probably realize that it's not the best DSL ever. Well, then you repeat. And then timeout comes. And then you see if it is okay or not. But this is a really easy way to create one. And then you can create things like that. I hope you will not need the basic language in Kotlin, but if you need it to share with some other people, maybe it will work out or something similar will work out for you. Yeah, missed thing. Or you may learn Ipsum. Well, I have a few minutes and I'll show you some existing DSLs. This one for the Kubernetes configurations. That one is an idea to do the XML binding with an expression here. So this uses this by delegated properties. So you can have the XPath-like expressions, which are the valid Kotlin expressions here. So with a slash, you decide, okay, I want to have this attribute from XML, or I have this child element, then that attribute. It's possible to do. The build DSLs or the build pipelines in TeamCity, at JetBrains TeamCity, you can use the Kotlin language to do this, the build definitions. It's something in the middle between the DSLs by itself or the APIs to create things, but it uses some patterns I've shown you today. Spring Framework, they use DSL-like definitions for controllers, or I guess after wiring. There are, of course, the inversion of control frameworks or dependency injection frameworks, which helps to use the DSL to bind together the components of your application. There might be the spec framework, which allows you to do BDD testing style with a Kotlin. Again, you see on the right that it is kind of similar. Or it is even possible to mix it to the yet another level, and it's called the scripting. So what you can do, you can use Kotlin as a scripting host. It supports the GSR for it, by the way, or you can use it like in a Gradle. So they host the Kotlin scripting and they allow you to express your builds with the Kotlin code instead of Gradle. Or you can just turn it into just a scripting engine, so you can create your executable files with the kscript, and there you can use your Kotlin, which is compiled and executed from a shell. And you can do the high-level automation out of it, kind of easier. And with even with Maven dependencies on the sources you have. And of course, there are more. And if you create something or use something, just take a look or say us. It's fascinating. And this the link where you can find more information or the all information about the Kotlin. And probably you want to try Kotlin coins. This is a tiny examples or the tasks which you can solve in the IDE or in a web browser to master the skills. Of course, if you have not enough time to code something real with Kotlin. And the Kotlin stack is a good place to ask questions. And at that moment, exact on time, we're going to have a 30 minutes break. And after this break, we'll speak about the multi-platform projects. How would you reuse the Kotlin code between platforms? And then we'll speak about the coroutines. So if you have questions, ask me, I'm here, or tweet me, or whichever you like. Thank you for the first half. Okay. Hi. So let's start the second part. Thank you for coming. Who is new in this room? Oh, few people. Thank you. We'll never know who has left this room, right? But, well, so the break is done. We are all here. We have new powers. And let's start. We have two deeper topics this time. The first one, this is a multi-platform project. This is the thing which we are working on right now with Kotlin. This is experimental, but you're open to try it. And the second part would be coroutines, which are not experimental. They are supported in 1.3. Okay, let's start with the funny part, the multi-platform thing. And right now, so this part I will not be show you the language features. Instead, I'm trying to ask you to think about, well, your application which you are developing, or some ideal application. What you have there. And the thing is that you may have a mixture of different technologies, languages, JavaScripts, and so on. For example, let's consume we are trying to create, say, the mobile application or the website plus the server side or like something similar. Well, this is a mixture of things. And is it good? Well, this is our technology, this is our ecosystem. We have to have so many languages. But how we mix these languages? It then turns out that we have to mix languages. And this is an example from the JavaScript side. But still, the idea is that they use CSS inside the string template, inside the JavaScript, inside their React, inside their runtime, and so on. And well, you may think, okay, these are the JavaScript part, and they have something strong, strange, different, not fast enough. Technically, we do use the similar approaches for years. And here an example of SQL. What we do? We do mix SQL with Java to run queries. Well, normal, right? And this is thanks to IntelliJ. It is able to at least highlight this SQL text. But normally you have like just a string or a concatenation of strings. Should you never do it, by the way, it's too dangerous, but sometimes we do need it. We do concatenate strings to create HTML, XML, JSON. Why don't we bother with libraries? Well, it's longer. Well, sometimes it doesn't work this way. But still, we mix languages, and we can mix languages in this way for some reason, unknown reason. But let's step back from it and take a look. How would we do it if we would be able to use fewer languages? And let's assume even one language. What we do, how we win from it? Well, technically we win because we can reuse things in the wild here. Well, that example with the CSS is, say in a CSS you have some border with some 5 pixels. Then you can use it as a constant and reuse it from some other side of your JavaScript. Well, technically, I'm not the JavaScript developer, so I assume that it is not possible to extract the CSS to this value easier way. Or we may reuse the field names or column names from our SQL query, just as a variable in our program, and then reuse it even rename it, well, don't rename columns in SQL. Someone probably have tried, but the small databases, it's all okay. Yeah, I know. And finally, we come to the idea of the multi-platform. So if we use fewer languages, we can extract the common part, and then we can use that common part on both sides or all sides of our program. It is not only the column names or the offset names, it might be the data transfer object, it might be some utilities, it might be some validation code, business logic, the part of MVVM, or, well, mostly anything. From the other side, if we use code, we should still use our platforms for the rest. We should not reinvent the wheels. If we reinvent the wheel, well, it is all the time good at starting at the beginning and kind of problematic at the end. Well, and with Kotlin, what you can do, you can use the different targets of Kotlin for different parts of your stack, like the Kotlin Gradle for builds, the browser for Kotlin.js, the server side with, well, oh yeah, this is a Java conference, so with JVM, or probably JavaScript, if there is a reason for, and then the mobile apps with native for JVM or even JS, or like a mixture of technologies. But the good thing, you can reuse it, the common parts here. And as for platforms, I guess you know it right now. So this is a JVM Android native with iOS in the browser with JavaScript. But wait a moment. I'm not trying to say that it's a good idea to grab your favorite jar to run it on native. No, I'm sorry. There are other technologies to achieve this. Again, it is not the thing to take your JavaScript library to run it on the JVM backend. Of course, there are good solutions for it, or Growl or something. It is, again, not to take your native library to run it in the JVM or JS. So actually, all combinations which you may create here, they are all saying no. This is not the approach. Instead, the approach is the common code. So what you do, you have the common code in Kotlin, which is essentially just Kotlin code with a standard library and other common code libraries, nothing more. And you can declare some platform expectations with the expect actual keywords. And what it means, you technically create some expectation, like say you're working with a JSON. You say, okay, I need these few APIs to do with the JSON, and you do expectations in the common part, then you can implement the whole common part. And then at a very given platform, say JVM, you use the existing libraries to deal with JSON to implement those gaps, and so on. On JavaScript, by the way, the JSON is a trivial thing to implement, so you don't need to use any library. So the idea is as follows. So you declare those gaps on the common part, and then you fill up those gaps from the platform-specific part. And this is how you create your multi-platform library. So more detailedly speaking, it looks like this. So you create those gaps. You may think of those gaps as like, say, the H files in C or C++. So you simply say something which is existing. And then you say, okay, for the JVM, I can fill this gap with some Kotlin files, which can use JVM ecosystem, with my favorite library, with even a Java file, which is along with this thing. And that is it. So with the JavaScript, of course, you can use the packages, like we used in Java, so libraries, so the packages, and then you come up with something live. And with a native, it's interesting, because in a native, you have so many options. You can use the C library with exports, either static or dynamic. You can use Swift framework or Objective-C framework. So Kotlin native interoperates with both the Objective-C and Swift. Well, this is an essential thing if you try to create something for the Apple platform. And it interoperates with the C if you're trying to write some console applications, native applications. So it is included in there. And as for expectations, well, you have you may use this expect keyword along the whole app. You can say, okay, I want to expect the function, I want to expect the extension function, sometimes it's good, Or I may expect an object, class, interface, annotation, suspend, expect function, anything. Well, just a joke. Well, you can expect fun, actually. And then you create your library to use for all those platforms. And it's a point where you see that you are not alone. You can have a common libraries. The library which have the code and it is compiled to all platforms you need. So you can create your own library or you can use an existing library. So speaking about the JSON example, instead of reinventing the JSON, you may just assume some existing library for it or say replace JSON with HTML or something. It is that. So technically it looks like the same. So you have those gaps, you have the platform specifics plus dependencies to fill those gaps. And finally, you have your business logic or your UI part or your MVVM or anything you need to reuse or data transfer objects for networking stuff. Anything is there. And when you compile it, you have a specific result at the end. For JVM, of course, we have jars. For JavaScript, we have JavaScript file with a package manager with a standard, one of the standard approaches there. And for native, we have a specific format which is called klib, or we may have the Apple framework at the end. So klib is the libraries on the native part of the Kotlin, so you can depend from multiple klib libraries in there. And technically, this is the picture we may have like all over the place in math, like 4 blocks. The idea is that you depend from your common part, you depend on the common part of some library. But when you move it to like reality, you project these things and say, okay, no longer if I depend here on the common parts, on the platform part, I also have my platform part, which depends on their platform part. And the Gradle plugin helps to implement it as easy as possible. So you simply say, okay, I'm dependent on this common library from my common library, my common code, that's enough. The rest is created by Gradle plugin for you. So it is really not that complicated to use. And this is the plugin you may use. This is called the Kotlin-multiplatform. As long as we experimenting with this field, we used to have another approach before. So just if you try playing with that, make sure you use that plugin, not Kotlin-platform something plugins. And the good part is that right now, your common library, it is enough to have only one Gradle sub-project to fill it in. Well, and of course, as I mentioned, there are so many existing libraries here. And existing libraries helps us to implement the things easier without rewriting the whole actual and expected keywords. So it may turn out that if you use the libraries, you no longer need the expected and actual keywords, which I already explained to you. You simply use this common thing, and that's enough. And you may think about tooling, and of course there is tooling. And the good thing with the Kotlin 1.3, we have support for Kotlin native, the coding support with IntelliJ. And we are working right now to deliver the support for C-Line, our C++ IDE, and JetBrains app code for an iOS IDE, iOS and Mac IDE. So right now, the good choice is IntelliJ. And be updated. It may change soon. And as we used it before, I decided to try this technology by myself to understand how good it is, what I can achieve with that. And so I'll spend some time explaining the MyPad project, so the link is below. Well, what it does fractals. Do you know what fractals are? Good. Okay. What it is? Yeah, thank you. That is a multi-broad set. So that's good. The most fun of this, well, technically in my case, it was like a university exercise somewhere in the first or second year. It was like, okay, if you're able to program, would you please program this thing? It is pretty easy to program. It's a good task. And then the most fun of it is to zoom it. So by definition, the fractals are like semi-repeating structures. It's like sort of a definition, not that mathematical way. The idea is that you zoom it, and there you may able to spot something similar to what you saw before. like this one and that one. And then you zoom it again, and zoom it again and again. You may Google it and you find out the really good cases where you really see something similar. Well, and the fun of this application is just that. You zoom it, zoom it, zoom it, reset, and again. And, oh yeah, some math for you. It's a deep dive, isn't it? I'll leave it without comments. What you should know about this picture is like for every pixel you do some computation and then you decide the color. So that's it. And this is an app. So this is a client app for the UI, which runs in JavaScript. This is a server side, which runs in JVM. And there is native, which runs in the browser console. So those are 3 parts of my application. And let's go briefly through every part of it, and then I'll show you something interesting in the code. Well, the common part, it defines the algorithm to go through every pixel to render it. Then you can have it in the console. You know, if you are able to deliver the console application, you should do. I'm joking. And the essential thing is that I used exactly the same code to implement that one. And this is compiled with Kotlin native to native. It doesn't require any virtual machine or something. It just works. It just works more or less instantly, no matter it does some computations behind. And the program is created this way. What we have, in a common part of my library, I say, OK, I have no idea what color is. And by the way, on the console, I have 2 colors, the X and dot. A good definition, right? So what I need from my algorithm for rendering is that I need to convert the HSL color. This is a good color system to generate random colors, nothing more, to this color of my target platform. That's it. So I created these expectations. Then, in the native part of my program, I implement it that way. So I say, OK, I have 2 colors, which are constants, the white and black. And if it is black color, it's known for sure it's black on the picture, so it's dot or X, and I don't remember. And other colors, I have no idea about the color space. I just say white color. That's about it. Of course, you may probably use enum instead of or something shorter, but to shorter this code snippet, I did it slightly not this way. Well, and the implementation is as follows. So I have the common part. I include the expectations and actuals from my platform with dot and X. And that's it. I have this fractal. And at this moment, we switch to the browser. And for the browser, I have the good user experience. So this is the thing. And what I do, I render the fractal with a JavaScript with a low quality. And while I'm doing this, I ask the JVM backend to deliver me with a good picture, to send it to me. So actually, it is sort of a good user experience, because I have the fast response, or sort of fast response, and then I have a quality image at the end. And here, it is essential to have the same logic used from both sides. Otherwise, I have different pictures at the end. It's not the thing I want. And for the JavaScript part, well, technically, I failed the idea to use fewer technologies. That's a JavaScript, isn't it? But the good part is I decided to code this entirely in Kotlin. So if you wonder to see how it is possible, just have a look in the sources of my repo. And these are few examples. The first one is HTML. I use HTML because I use React, so I use this HTML DSL instead of JSX and a specific compilers. So we saw this example before, so I guess you understand how it is how it's supposed to work. Then, of course, we have code completion and stuff. I use CSS. Are you seeing CSS here? Somebody does. And this is kind of an example of the DSLs. Sometimes you're able to make it right. Because here you don't need to think whether it's CSS or not. It looks all CSS. But it is a Kotlin program. And this is the place where you can extract a variable to reuse it with your other parts of your application. Isn't that good? And finally, I do the typed React. If you do React, you have the states and the props, which are just JavaScript objects. And then it's really interesting to see the usages of some fields. With Kotlin, there's a Kotlin wrappers library which is on GitHub. You can try to do React typed. So you declare an interface saying, okay, this is my props. It has those getters and setters, only getters, by the way. And then you can use it. It allows you to do, say, find usages along with React. Isn't that good? Okay. Yeah. And the code completion, of course. Because this part which builds the React DOM, this is done with HTML example. So instead of JSX. And here you can extract your functions if you need it. But why don't you mix it with React? I don't know. And finally, I do use coroutines. And we'll speak about the coroutines a little bit later today. But the thing is that in a JavaScript, you have only one thread, technically. And you need to do the cooperative multitasking. With coroutines, it does really easily. So for example, here, if you do the hard computation, the browser window freezes while you're running it. So you have to split the computation into parts and do the rest with the set timeout or something. And instead of doing the set timeout the callback help, you can do it like this, with a yield function, which is a specific suspending function. So the execution of this function is suspended at that point, and when all events or queue is processed, it's resumed from that point to the end. This is all my journeys in a JavaScript part, and some more coroutines example to start two tasks, which are async, but they are running the same one thread of JavaScript virtual machine. And finally, the actuals. And for the actuals here, I use the library. In NPM, it's amazing because you have a library for anything and for the colors conversion as well. And so I use this library, I require it, I use it in my code to convert the colors. That's about it. And the process for me is as follows. So I have the common algorithm implementation, I have the color and the libraries to implement the color for JavaScript, through browser ecosystem, and then I compile it to a JavaScript file. And then I use this JavaScript file with a Webpack or something. In my case, it's a Webpack to pack the whole thing into one JavaScript file. Technically, you may run even dead code elimination here to make it more dense if you need, or uglify it to make it more dense and work faster. It's up to the stack you have in your project. And those are libraries. So this is Kotlin wrappers, Kotlin HTML, and Kotlin coroutines. The good part is, technically, I have no JavaScript in my project, no matter I target JavaScript. And I reuse the common part here. OK, that was JavaScript. And for the JVM, I think it's, so we all know JVM here, so it will be short. What we have the Cater, this web framework, web server, which does the web server part. It generates the PNG files and sends it to me. I use Netty or Jetty, so it is hidden in the Cater, so you may decide whether you want Jetty. I think I use Netty in my example. And then this is a DSLs, how you define a route for your HTTP server. Well, I guess you've shown similar pictures before. I've shown you. So this is how I do it. So what the nice thing about Cater here is that it integrates with the HTML DSL. And I can say, OK, let's reply with HTML. And here I have my HTML, nothing more. And below you see the implementation of the rendering method endpoint. And the JVM usage is trivial. In JVM, by the highlight of the JVM is that the color in JVM, we have java.awt.color, which I use here. So I don't need to create any wrapper class here. And this is how I call the same algorithm again. And this is how I implement the color. And unfortunately, in my case, I failed to find the library to convert the colors for Java. Of course, I can Google the formulas in Wikipedia, but it is not. So finally, I ended up having a Java source which implements this for me. So I use java.java file together with my Kotlin code, together with my common part to implement the whole thing. And the implementation is as follows again. So I use the common part, I fill the gaps, I include some libraries, in my case sources, and finally I have my class files. And as long as this is a Java conference, I guess you know what to do with class files. Do you? No? Okay, trust me, you can start it with Java-jar. Oh no, you can pack it to jar files, or you can create the var files if you still need it. And if you deal with the common part and the expectations, it could be bugs. And the thing here is that you can create the tests in a common part of your application. And those tests, this is yet another multi-platform library, which turns it into JavaScript tests for JavaScript, turns it into JUnit 4 or 5, depending on your dependency, for JVM, and it has the dedicated test runner for native. So what I do, I create the common tests, and I am able to make sure that my expectation and actuals will not break it, no matter how many platforms I have. So it's kind of write test once and debug those tests on all platforms. Yeah, this is a Kotlin.test library to make this happen. And yeah, so this is the JUnit for JVM, and I think the Jasmine or something for JavaScript, and then in native, Kotlin native, we have the test runner included. So that's our own one. And this is technically not the coding time, but I will show you some IDE with some snippets. It will not be that long this time. Let's see what we have. Well, remember I mentioned that you're able to target iOS as well. That's an example. So what we have in the code, let's see. So in the code, I have this common module, which is the common library. And it has several backends. It has JavaScript, it has JVM, it creates the framework for Objective-C and iOS, and it creates the command line application for me. So the code is as follows, as I shown you. So in the main part, I have the color declaration with expectations. I have the complex numbers and so on. And here I have the native part. So this is an iOS implementation. I have the implementation of colors for an iOS. And this is really nice. Here, what you see, what I do here. So if you're aware of something from iOS, this is a Kotlin native. It imports the core foundation or core UI framework from iOS, and I use it from Kotlin to serialize my picture into the CI image class, which I use from the Xcode here, which I use it here to show it as the image in my iOS app. So this is a rendering code. And if you take a look into compiled parts, you see here, you see the framework. So the Kotlin native is able to create an iOS framework for you. So you can just use it. Similarly with the JavaScript. So if you open this one, you have a JavaScript here. This is my JavaScript. And remember I told you that it's more or less readable. Well, it is. As long as you know what it does, of course, because without knowing what it does, it is like magic. Well, yeah, let's switch back. So at that point, you may think, or I may think, what I can do more to this example. And the first one may be, okay, shall I probably try to use the services instead of microservices? Lambdas? Well, I can turn it into Lambda. And technically, I'm not that concerned right now saying, okay, whether I need the Lambdas which are JVM only? Not really. I can deploy the Kotlin JVM to, say, Amazon Lambdas. I can compile the same thing into JavaScript and deploy it to other cloud providers. It is all for me. So I'm no longer like bound to the backend, to a target platform. Or I may even compile it to a native and deploy it somewhere else. It's up to me right now. And I started doing some iOS, and you've seen the example in the iOS device simulator. It is possible. And probably I'll create a tap and zoom feature for a mobile device, and I'm not sure whether I use some common part in this example, or I will stick back to existing libraries for every platform. I think there should be some. I have no idea right now. And the point is that I can code things once to deliver things to all platforms I need, and I can reuse it for all applications, for all targets of my applications, be it the server side, client side, mobile, or whichever. And here it's probably yet another examples of the full stack applications, and I guess the best one is the application from the Kotlin Conf. We had Kotlin Conf several times, several weeks ago, and there of course, we had an application which was written in this technique. And that is the time. And this is an application. Of course, we had the common part, the iOS, Android, and the website. And again, our favorite link I shown you here as well. So if you're looking for more information or tutorials, that's the way to go. There are so many things which technically does not fit into this talk. Well, this is the end of this part. And if you have questions, you may ask here or on Twitter. And we're switching to the next thing. It is the coroutines. Okay. No questions, so we continue. Well, do you know something about coroutines? Have you heard this word before? Few people, okay. Well, this is nothing new. Of course, you heard this word because I told it several times today, right? So few hands, it's good. It is nothing new. It was invented, I guess, in '57, if you take a look on the Wikipedia, and they published some paper about it, I guess, in '63. It's almost 60 years now. Nothing new. And the idea is as follows. You have a function, but you're allowed to suspend function at some point. And then the stack is free. That thread is not longer working on this function. And then you're able to resume execution of that function from that point to the end or to the next suspension point. That's all about suspension functions. And let's take a look at an example. This is an ordinary application. What it does, it downloads some page, and then it tries to show, print, whatever. And if we start doing it from our UI application, the graphical application, we'll probably have something like this. Well, sometimes it may happen that I have the not that fast internet connection or the noise in the channel or something, and so this takes longer than I expected to download 0 terabytes, say. Well, and then you may find out something like this. Oh, I see somebody remembers those times. I think it was Windows 98 or the operation system where it was only one thread and anything was done in a cooperative multitasking way. Well, this is what happens. And okay, this is a problem. Everyone knows that is a problem, and our industry knows the answer. Let's do asynchronous, right? So instead of writing the code before, we do something like, okay, let's download something, and when you're done, please let me know, I'll update my UI. At that point, you realize that the show function, is supposed to work from a multiple threads, but okay, we'll fix it. And finally, we are set. But the difference is that if you have more or less non-trivial code with callbacks, you have several times more non-trivial code with callbacks. But the ideal thing is to have something which looks like before, but which works like we need it to without blocking. And this is a coroutines. And the coroutines are possible in JVM. I tried to Google it, and I was able to find some examples. Of course, yeah. The Project Loom. Do you know something about the Project Loom? Really? One hand? I don't believe. Two? Okay, thank you. It is something you might want to know. This is the future of the JVM platform, actually, one of several projects. And the idea is, if you take a look on the text, their description, their motivation, you'll find out that, well, the threads in Java are not the amazing thing. Technically, you cannot start as much threads as you need. You're limited, and threads are operation system backed. It is hard. And all the things, if you may read it there, all the things with asynchronous programming were probably brought to the world because we are not able to use threads in the way we like it to. That's why we need to limit the number of threads and do callbacks. Probably it should be something else. And, well, it is what we have. If you don't want to wait for the project loom to release or for something to try, you may want to see if it is possible to have the coroutines implemented on top of the JVM, not on top of the platform, but on a bytecode level, on a level of the language. And technically, I was able to find some 3 or 4 projects. Unfortunately, they are not that popular right now, or probably dead. And one project was a fork from another with one committer. There are different languages which do support coroutines, or they may call it the generators, yield returns, async await, the features like dealing with coroutines to deliver some effect for us. And I decided, of course, to say a little bit about the Kotlin here, but I'll try to show something else as well. And with Kotlin 1.3, we have coroutines included. It is a supported feature. And it is not only for the JVM, but for the other multiple platforms we have. And it is Apache 2, so Kotlin is open source, and you might take a look how it is implemented if you like. And all these platforms are our friends here, of course. And Kotlin native too. So let's turn back to this example. Here we see the suspend keyword and the code. The idea is that this one is running on the UI thread, and the open function suspends the execution, and that means that the UI thread is no longer busy with us working on this block. The UI thread is free to do whatever it likes, and once we have this text downloaded, we resume this function saying, okay, it's time to do the next piece of work. That's cooperative multitasking, nothing more here technically. Let's see how it is. So the first part, that's the rule, you can call whichever function you have from a suspend function in Kotlin. But you cannot call a suspend function from an ordinary function in Kotlin. This is the rule. So if you need to bridge from a non-ordinary function to a suspend world, what you do, you use a specific function from the standard library or another library. So the implementation of this magic in Kotlin is done on top of the tiny part. So the tiny part of the features is done on the compiler level. It's essentially the suspend keyword in the language. This is the all language changes we have to implement the whole thing. And we have the tiny APIs in the standard library to build this bridge, to start a suspending function, and to suspend execution of a suspending function. And the rest is done with the libraries. And it might be you to create yet another library to solve your particular problems. Of course, if you want to, or if you don't have an existing library to solve it. And here's the really great example, and we will speak about this library. It's called Kotlin-X.Coroutines, which does mostly anything on top of their standard library. So it's replaceable, updatable, and it is not bound to the language. And let's start with a really simple one, the generators. In JavaScript, I guess it's called generators. In Python, probably generators too. In JavaScript, in C#, it's called the yield return. The concept is, say you have a sequence of something, and you're able to iterate through the sequence, but you are lazy to implement the iterator with a get next. Of course, there are some libraries which helps, but still it is tough. But let's consider the Fibonacci sequence. So this function, well, the sequence is the function which takes a lambda, so the block inside, it simply generates the infinite sequence of lambda, of Fibonacci numbers, right? And it uses this yield function. The yield function is a suspending function. What it does, it stops execution on that point and resumes the execution when I ask for the next element from my iterator. And speaking about the bridge, this is the way to start this coroutine. By the way, this coroutine has nothing to do with multi-threading. This was just a code which creates an iterator for us. And this suspend function that takes the suspend lambda as a parameter, but it is the way how we have this coroutine to work, to start it. And this, how you start it, so you have a suspend function with lambda. So the suspend keyword you can use with functions and with lambdas as well. So that's just a keyword technically for us. And finally, I want to ask you how this works. So you see here in this example what I do. I take 10 elements, the last lines. I take 10 elements from this sequence, and then I want to print them, right? And I have yet another debugging information just inside this lambda, so before the yield. Well, do you think it will even kind of stop working at some point? A good guess. Or another option could be like, it will not stop. It will work eventually, eternally. Here's the answer. Well, thank you, you were right. So, how it works? We need the first element. So we start running this function under the sequence, and it runs to the yield. So the yield is a suspending function. So when you call the yield, it suspends the execution at that point and returns us the first element of the sequence. So we print it twice, first with the yield, the second one with the got. Then we loop to the next loop and go and ask this to get the next element for us. So this function is resumed from that point to do the next iteration of the loop. And if we are not asking for the next elements, this function is not running. And the whole thing runs within the one thread, no problem. So we do it. So this is the coroutine in action, technically. Well, the coroutines are designed in a way so you can use it from your libraries. So you can create your own way to start your own coroutine on your own rules. Or you can use an existing library or the standard library to start a coroutine like I've shown you before. And right now we'll take a look what we have in the Kotlin X.coroutines library. There are many features in there which deals with the concurrency or not blocking stuff. And this library, it's done by JetBrains, it's open source, it is not the same code base as the Kotlin, it's near the Kotlin along, and it is Apache 2, and it is here. And it is, by the way, the multi-platform, meaning you can use the same concept for JVM, for JavaScript, and native, the same APIs. Of course, for JVM, we have bigger APIs in the platform part. For native, we have shorter part, but still. And okay, remember this one? And I'll show you how you can implement this one with standard library. Let's see. So what we need to create the suspending function open. And you can implement it this way. Unfortunately, there are so many lines here. But let's start from the first part. The first thing we do, we start an execution. And assuming we have a completable future out of it, or something similar, right? So we have some another thread pool, or something which does the download for us. The next thing, we call the magic API function, which is called suspend coroutine. And an exchange is that we have the continuation object. So the idea is that we remember this continuation object and we leave this function. So all functions at that point are no longer running. The stack is free, thread is free, anything is free. And we can resume the execution by calling this continuation object. And normally what we do, we subscribe on our future in some way. Of course, there's supposed to be some APIs to know where some asynchronous thing is done, right? And when it is done, we say, hey, continuation, let's resume the execution from that point to the end. And of course, it might be the case where it failed. Then we can say something like this. We may say, let's resume the execution with an exception. So for the code which calls this function, that calls the open function, it means that we'll have the ordinary exception in Java or Kotlin or whichever. But it will be ordinary exception. You don't need to mess with the callbacks. Instead, you just handle it the standard way with a try catch. And finally, it resumes here. So either we have an exception here, which may try catch or just don't catch. And in case it is okay, we have the string value returned. No matter how complicated is the background activity of this. That's the point. And now let's take a look. So now we know how it looks like, and let's take a look on our applications. How do we implement them? And here are several things. The first one is the performance. So technically, if somebody will ask me about the performance, I'll have some picture like this. This is all fine. No, my application is performant enough, no matter I need 1,000 machines for it. Who cares? It's okay. And then you try to put it on one laptop, and then it's a different story. But still, I decided to do trivial math. Say we are able to run a little bit faster, then we can consume less resources and win something. Well, it makes sense. So technically, if we are able to use non-blocking thing or something else to speed up our applications, it is something we might probably need to try. And at that moment, let's see how we do our apps. And well, I cannot say I have silver bullet here. I do not. But there are two approaches. The one is the blocking, like say the servlet API 2 or something like. We have one call to process the request, and this is a one thread which is bound to this request. The second approach is to do non-blocking stuff like probably netty or reactor or anything like that, where we try to say, okay, we try to do more requests within fewer threads. Sometimes it's good, sometimes it's really, really hard. And this is an example we will go through. What we have, we create a service which calls 3 more services to deliver some result for us. And if we start with a blocking approach, this is how I would implement this. Let's assume that the println is the magic function which does the way to return the value from our service. Let's don't get bothered with the specific APIs here for the sake of this example. And how it works? Standardly, it blocks to call the first service, then it blocks to call the second service, and so on. Blocking approach, nothing specific. And as I mentioned, the good part here is it's so easy to write, debug, deploy, diagnose, test. So easy. The code is pretty clear here. Nothing specific. And here comes to the motivation from the project Loom, where we say, okay, threads are really, really good as long as you have few threads. But if you have so many, but the problem here is that you have this service, it works really good if you have 100 requests in parallel. But if you have 10,000, well, you have a problem because you're likely not able to have so many threads working for you. So you'll have long delays to wait for the request and being processed, and then, or maybe it's okay for your SLA. And then, if you use threads, you might think about some caches or state, and then you know something really nice about the Java memory model. Java memory model, you know it? Okay, I know you're doing some concurrency, I guess. Okay, and this is so hard. You might not believe me. Okay, that's okay. But I decided to try. So I decided to see how many threads I can start. And this is my application. Well, I decided to start 1 million threads. It's not that big number, right? Okay, so I start thread, and I just decided to wait for all threads to start. That's it. I don't do anything. Do you expect it will work? Well, you'll see something like this. At least on the macOS. So you see, okay, no luck. And then I decided to see how many threads were there before it crashed. And these are numbers. Well, in my case, And it's clear that it depends on your operation systems, on the tuning, and so on. In my case, it was 4,000 on macOS and 12,000 on Linux. And then I decided to see Windows. Well, this is a time in hours. So technically, if you have 2 hours to start your microservice, well, probably you're set. These are numbers. In my case, in my Windows 10, I had this one. So I started it in 2 hours. I realized it's only 37 gigs of RAM. Well, are you okay? There is no state, no data in this program, but 37 gigs you need to spend. And it is really, really good article by Mark Rusinovich explaining why it is even possible. It is cool. It is interesting to read if you want to know how the operation system is implemented inside. It's something. And then I forgot about this example. And the next day, I found 65 gigs of RAM. Well, if you have 1 day to start your microservice, okay, you're done. Let's summarize what we have. So on Linux or Mac, you're pretty limited with a number. On Windows, well, I guess it is possible, but then you know that the context switch, like when one thread is suspended and the other thread is started, it's not cheap. So if you start so many threads, you'll probably start noticing that the context switch takes time. So that your processor is technically on the machine is doing nothing but switching from one thread to another. It's like a multitasking when you keep answering questions from people on your team instead of doing something useful. But answering the questions is useful, isn't it? Okay. And then I did yet another tiny experiment. I created a semaphore, and I started seeing how, if I have 4,000 threads, not much, and I'll block the thread to update some counter just for fun. And then I realized that there are threads which are happy to execute, other threads are unlikely to execute. And then you find out that if you create a semaphore in Java, you have the fair parameter for it. And if you do fair, well, you sacrifice the performance several orders of magnitude. It is not free. So this is how we do threads. Well, if we still think about threads, okay to say for a microservice, it's okay to say, well, we need to scale, let's start more machines. Who cares? It is microservices, they're supposed to work. It will unfortunately not work this way if you're speaking about the desktop applications or mobile. What else can we do? We can do non-blocking, or we can take a look if it is something to try with the project loom, with the fibers. They call it fibers, but the new threads, which are not technically threads. And by the way, I decided to see how it is with coroutines. So the same example, I even simplified it a bit. So instead of doing the barrier, I just decided to have a delay. And the trick here is that it works. It was pretty fast. It consumes not much memory. The reason is that it technically allocates 1 million of objects on the heap. Okay, it is nothing serious for the JVM. But it doesn't use threads. The coroutines here are not threads. They are using threads to execute part by part. So if you take a look here, you see that the delay function is a suspending function, which technically sets a task for an executor to execute it a little bit later in the future. So this program will work something like 30 seconds, because the delay is 30 seconds, plus something small, not longer. And right here, what we can find, we may see that the thread, it is being suspended in random places, which how the operation system decided to. But the coroutine, you have a little bit of control here, because the coroutine is able to suspend calling a suspending function, no other places. So it gives you at least the power to make it more safe and avoid the shared mutable state. But of course, it doesn't guarantee you anything. Well, let's turn back to non-blocking. So the non-blocking thing we use the callbacks like this one. Or if you think about the problems or exceptions, you may use things like that. So you have the callback with 2 parameters, or maybe 3 parameters, or maybe an observable pattern or something. And in a non-blocking approach, we say, okay, we are no longer bound one request to the thread. Instead, we use a few threads, like comparable to number of CPUs in the machine, to process anything for us. And right now, it is harder to code. And if you don't believe me, here I have an example. Let's assume you call several functions with the callbacks. And you simply need to wait for the result of this n callbacks. Well, if you think it's so easy, you may try to code it, or you may take a look what you have in an Rx and a zip function. It is not that so easy, taking the concurrency into account, of course. And here's our example with a microservice, and what we have. We had this one, and it doesn't work because it blocks, so we create this one with the callbacks. So far, so good, isn't it? And then we see some touch of reality. And we realize, okay, we'll probably need error handling. Okay, we'll probably need cancellation. Why not? Sure, we do. Then we need a streaming of results. I'm joking. We are okay without streaming of results. And finally, we have 2 to 3 parameters or 2 to 3 methods on every callback in this picture. And it would be this. Sorry, you are not able to read it. But you may download my slides to see, right? But the essential part is at the end of this, is this. And you know how you program the asynchronous application? You just move the code to the right. Just select it and press tab to move it a little bit. And then a little bit more, and then a little bit more. And finally, we have application, which is work. And the problem here is that it is hard to support, one. And the second is that if you try to update somehow a little bit this application, you'll probably end up rewriting the whole that mess. Because you need to a little bit change the order or error handling or something. Okay, try. Well, and I'm not the only one understanding it's hard. And of course, we have libraries to solve it. For example, we do have promises in JavaScript. In JavaScript, the situation is horrible. They have only one thread. They have no thread pool. So they need to take care and use something to, well, to deal with these brackets. Or in Java, we have completable future or something similar to completable future to have a callback on something which is done somewhere. We have reactive extensions, or we have another libraries which do essentially the same idea. And the idea is that we are no longer writing the program. We are creating the pipeline. So we say, okay, let's create that pipeline, and then we execute it somewhere in the future, somehow, no matter how. So if you say that the future on complete something, you have no idea where, at what moment this on complete will be here. And then if you have some side effects on your callbacks, then it's good to debug. You have no idea when it's called, and then, well, it's hard. And to play with Rx, you need to implement like 3 methods to follow their contract of observable. If you can use Rx operators for the rest. And for example, this is how you implement the observable for our case. And finally, you can do things like that. So to wait for 3 callbacks, I call this zip function, which waits for 3 cases, and then I can aggregate the result. Well, good enough, but technically, this is yet another language in a language. And some time ago, I heard this thing saying that the JavaScript and jQuery, they are different languages, essentially. The JavaScript is a library for jQuery is a library for JavaScript. Well, old joke. And this is the way we define pipeline. Then we execute it. So technically, we learn something new. We learn definitely new language out of it. But there is yet another approach, technically. And if we turn back to this example, You see this, the highlighting on the left, and this is the old change. So we use suspend functions, and we implement this one. And the thing here is that behind, if you take a look on a bytecode or somewhere, it will execute with a callback fashion, as a callback, non-blocking stuff, and so on. But to us, to readers, this one looks, well, readable. At least to me, because I'm not an expert in ARX. So how it is possible? So this is a linear code, as I mentioned. And the good part, here you can say, okay, I want to try catch something. I want to loop over something. I want to do anything I used to with the standard syntax. You don't need to learn the operators to deliver this. And this executes asynchronously, step by part. And let's take a look how it works. Well, so we have on the JVM level first, yeah? So we have this function, right? When you compile it, it will be something like this on the JVM level, but you'll probably not be able to call it because it has specific attributes to protect you from calling it directly. So the change here is that it is the function with a callback. The callback here is a continuation. And then this is the continuation. It has some scope, some state. It is necessary to implement when you try to implement your libraries. And it has the resume method from the result object. The result object is either the result or an exception. Nothing here special again. So this is how it's being compiled. And then when it executes, you may think it executes this way. When we go to the first suspending function and the function suspends, it means the rest of this method comes as a callback to it. Then we go to the next step, and the rest of this method comes as a callback, and so on. But the thing is that it creates a state machine inside. So it splits the code into tiny parts. Every part updates the state and returns. So when the function is suspended, it no longer consumes the thread. So your thread is free to do whichever it likes or free in the thread pool and so on. And when you resume it, it again starts to execute on some specific thread to continue. So this is technically done with the state machines. And the state machines allows you to do both. It allows you to do with the concurrency thing, and it allows you to work with the generator example as we had it before. Actually, the same mechanics. And now we can do something like this. And you might just try a mental experiment. How would you implement the same thing with the Rx? Well, I guess there is a specific operator to handle an exception there as well. But this one is readable, for me at least. That one is good, but you need to know what you do there. And everybody in your team should be. Well, of course, there are non-blocking with the language support as well. And there are languages like, say, C#. In C# you have a async await thing. You have a yield returns. In Python and JavaScript, there are all those features. But from the side of the user of that language, it looks like something different. Well, I heard the stories like in C# probably the async await grew up from the generators and yield return, but I don't know for sure. But from the Kotlin side, it is a little bit different. The Kotlin gives us the standard thing, one thing with a suspend, and then it's up to libraries or the parts of your code or library code to implement the magic on top of it. To implement async await, to implement generators, anything you might want to. And let's take a look on async await pattern a little bit. Well, so what it does here, it does this. So with Coroutines, Kotlin Next Coroutines library, you may have the code like this. So what we do, we start asynchronous execution of a call to service A, to call service B, and call to service C. You may read async as something which is post a task to an executor service, for example. Or you may read this async as something which starts the process somehow within the same thread. It is hidden in the implementation detail of the way how you start this coroutine. But the good part, we see that we start free concurrent operations here or cooperative operations, depending on the site. And then at the end, we call await to get the result out of it. So easy. And now we see how the await function is implemented. So again, so the await function, you may either have this await function implemented for your framework or your library, and the Kotlin X coroutines have enough bridges for it on extension functions. Or you can create an await function for your case, for your special case. And then you create it like this. Probably you create it as an extension function to some object you have in your program. And it does the main thing. It does suspend coroutine call. And it exchanges you with, it suspends execution and you have a callback. And then you call this callback somewhere in the future. It's at the place you like it to resume the execution. And the time in between, it is free. So technically this function returns, saying from the JVM level, from the state machine level. It returns. It no longer consumes the CPU for it. It is there. Well, this is how you can connect it to your application. Let's take a look at an example with awk HTTP. Well, the awk HTTP library has the function you call, this is their function, and await is the function I created here. And the await function for awk HTTP is created this way. I do call the enqueue. The enqueue is the method from awk HTTP on the object call. It does the execution, and it accepts a callback. I implement the callback here, object call, and so I create this callback interface. And when the awk HTTP is done processing my query, I do resume my execution. And that is it. So if you use this part with the example before, this is a workable code snippet. So this is how easy you can connect the coroutines and Kotlin X coroutines library to your asynchronous computations, if you have it. Similarly, you can do it with a gRPC if you like. So nothing, again, the call is the method from a gRPC to generate one from your protobuf declarations. And then it accepts the stream observer from the gRPC. So I implement this one, and I have the callbacks when the data is there and the call is completed. I do it this way. So again, it is easy to connect it to something existing you have. And for the Kotlin X coroutines library, if you open it on a GitHub in a README, you'll find out that there are so many things which are actually supported by the standard implementations. Or if you're looking for some others, you might just contribute, if you like. And the one thing to the end, this is a shared mutable state. So the idea is we may think that the shared mutable state is a danger. You may realize that, okay, if you change some variable, you need to have the decent blocking to make sure it works. Then you need to learn the Java memory model, and well, it's hard. There is a replacement. There is a channel in the library. And the channel is actually the channel and the readable and writable channel. This is a synchronization primitive which helps us to deal with the concurrency. So for example, we try to isolate state. We may create an actor or just a coroutine which encapsulates the state inside. So it will look like this. So you just start it. It has the state inside. It iterates through the channel, and the iteration through the channel suspends. So it does not consume the whole thread for eternal. It just resumes to do some work and suspends again. And the channels are designed to make this possible. So you can now pass the data through the channels to this actor. And the trick is that it will work even with JavaScript with one thread or with a thread pool. It is the same code to work. Similarly, you can create the workers. And so you start the workers, you start each worker, and it takes the element from the channel, process it, and send it to the other channel. And this is a way how you create the communication between your coroutines. So easy. And then if you start playing with that, you might realize that, okay, you can create the huge computation schemes with a safe and thread-safe things. So you actually no longer need blocking from one side. From the other side, you understand that you are safe doing this. You will not fail with the synchronization stuff. And you might know something similar from a Go language. They have the select expression, and the Kotlin X coroutines provide us with the select expression as well. So the case where you want to read from several channels, or you want to post into several channels. And again, the whole thing works no matter how much threads you have in your application. From the other side, if you have an infinite set of threads, you may overload the thing. Like if you do the download from the unlimited set of threads, well, probably it is not what you are trying to achieve. So the Kotlin coroutines, you have a suspend keyword, and the rest is done in the libraries. And you can create your own if you need it. Or you may use the existing one, that one. Well, and to the end, it is not only for the JVM. The snippets I've shown you, they are more or less okay for other platforms too. So you may try using your coroutines in your code, and probably it will help you to make your code easier to read, but still asynchronous and fast. And if you want to learn more, I do recommend you this video. This is from the inventor of coroutines, Roman Yelizarov. Take a look on this on YouTube. It is from Kotlin Conf this year. Well, just take a look at the name of it, and well, it's a deep dive. It's even deeper dive. And well, we have few moments for the summary right now. So this day we were speaking about the Kotlin. It's a statically typed programming languages for multiple platforms. And remember, I shown you the iOS example, I shown you the DSLs examples, and much more. This is how you can create your applications and cover the whole stack of it. And this is the modern, of course, language. So you have the functional programming approaches like passing a function or lambdas as a parameters and so on. And you can target as much platforms as you like, and you have a concurrency, and we have an IDE support. Of course, we do have much more. And by the way, at the end, at JetBrains, we use Kotlin, I think, in the most projects. So all products we have which uses Java inside, we use Kotlin in there as well. And there are some experiments where we using the Kotlin for JavaScript UI and for most of the full stack things. And these are, I just like this picture. Those are the logos of the products we have where we have Kotlin support inside. So with Kotlin inside. But of course, we are not trying to rewrite anything with Kotlin. We just make the Java and Kotlin coexist in our projects. And if you decided to try, probably writing unit tests is a good thing to try. Or creating a tiny microservices if you do microservices. Well, at the end, the Kotlin 1.3 is here. You might try it. It gives stable coroutines. It gives Kotlin native beta and much more, like inline classes, for example. So you may take a look on this on the website and see what it is, if you need it. Probably you do. And well, this was the sign and probably the end. So this is the good link to try. And so if you have more questions, I'm here to ask. I'm here at the JetBrains booth as well in the expo area. Or you may tweet me if you want just to know something else. Thank you for your time.